Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from May June 2023, Paper 1, Variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of AS Physics. Then also you can have better understanding of these questions. Let's study together, let's improve together. In today's lesson, we are talking about May June 2023, Paper 1, Variant 2. And total time for this exam is 1 hour and 15 minutes, and you need to answer all questions on this paper. And there are total 40 questions on this paper. And total mark for this paper is 40. On the second page of your exam paper, you can also find some important data, and also some important and basic formulae are also given to you. In the exam, if you need value of any constant, or if you have forgotten any formula, you can come to the second page of exam paper and you can find values of constants, and also you can find some important formulae. Question 1 says a stone sinks in water. What is a possible value for the density of the stone? So first of all, we can simply imagine we have a beaker, and this beaker is filled with water, mean we have some water inside this beaker. And now if we place a stone at the surface of the water, this stone will simply sink. So stone will stay at the bottom of the water. As this stone sinks, it simply means that the density of the stone has to be greater than density of water, and density of water is equal to 1000 kgs per cubic meter. Now if you look at given options, for option A it is given to us 8 times 10 to 2. It simply means that this is 800 kgs per cubic meter. If this is the density of the stone should float at the surface of water. If you look at second option, this is 2000 kgs per cubic meter, and this density is greater than density of water, so it means in this case stone will sink if this is the density of the stone. So this can be our possible answer. But if you look at option C and D, units are newtons per cubic meter. So here we have newtons per cubic meter, here also we have newtons per cubic meter. So we can check these units. Are these units of density or not? Newtons per cubic meter, so we can write down this is newtons. We have per cubic meter, and for newtons SI base units are kgs meter per second square, and this is meter cube. So if we simplify this one, we can write down kgs. We have meter here, so this is m to the power of -3 and s to the power of -2. So we can write down this is kgs, m to the power of -2, s to the power of -2. And these units are not units of density. So it means option C and D, they are not possible answers. A is also not possible answer. So the answer for question 1 is B. Question 2 says gigameter, terameter, micrometer and picometer are units of length. Which unit is the largest and which unit is the smallest? So simply we need to understand the meaning of prefixes. So first one we have is gigameter. G is representing giga, and 1 giga is equal to 10 to 9. Next one we have TM, means terameter, and T is representing tera, and 1 tera is equal to 10 to 12. Next one we have is micrometer, and mu is representing 10 to -6. Next one we have PM, and P is representing pico, 10 to -12. Question is simply asking you which one is the largest. So tera is the largest, means this one is the largest one, and this one is the smallest one. So we have largest, this is the largest, this one is the smallest. So the answer for this question is D. Question 3 says two measurements for a solid sphere are shown. Mass is given to us, diameter is given to us, and the absolute uncertainties are also given. These values are used to determine the density of the sphere. What is the percentage uncertainty in the density? So first of all, we need to understand density is equal to mass over volume. So the percentage uncertainty in density, we can write down delta rho by rho multiplied by 100. So this is the percentage uncertainty in density, and this one has to be equal to the percentage uncertainty in mass. So we have percentage uncertainty in mass here plus percentage uncertainty in volume. So we have absolute uncertainty divided by the volume multiplied by 100. For the mass, we can simply write down, we have the absolute uncertainty, we can divide this one by mass, multiply by 100, we can calculate percentage uncertainty in mass. But percentage uncertainty for volume is a bit tricky. So first of all, we can write down volume of a sphere. This is equal to 4 by 3 pi r cube. But in this case, we have diameter instead of radius. So we can say 4 by 3 pi. So here we have diameter. We can say this is d by 2, means this is equal to radius cube of this one. Now, if we simplify, we will get 4 pi d cube divided by, we have 3 here and we will get 8 here. Now we can cancel this 4 with it. So we left with pi by 6 d cube. So this is the volume. But if we look at this one, pi over 6, this is constant. So when we calculate percentage uncertainty, we don't consider constant numbers because they will be simply cancelled. So we can write down delta v for v from here. This one has to be equal to delta d by d, and if we are calculating percentage uncertainty, we can also multiply this one by 100. So let me rewrite this part again. So to calculate percentage uncertainty in volume, simply what we need is delta v by v multiplied by 100. This one has to be equal to delta d by d multiplied by 100 and multiplied by the power of d. So it means we can simply replace this one with this. We can rewrite here. So we have, this is delta m by m multiplied by 100 and plus we have 3 times we have delta d by d multiplied by 100. Now simply we need to plug in values. So we have absolute uncertainty. This is representing delta m and this is representing delta d. So we have 0.1 divided by 32.5 multiplied by 100 and we have plus, we have 0.04 divided by 1.87 multiplied by 100. Now simply we need to solve this one. If we solve this one, we will get 6.72. Percentage uncertainty should be written up to 2SF. Up to 2SF. So our final answer has to be 6.7. So the answer for this question has to be D. Question 4 says an aircraft travels along a horizontal path. Two of the forces that act horizontally on the aircraft are thrust force of the engines and the force due to the wind. The vector diagram for these forces is shown in this figure. Which factor represents the resultant horizontal force acting on the aircraft due to these two forces? So we have force due to the wind, we have thrust force of the engines. Simply we need to find the resultant force. In order to find resultant force, simply we can use parallelogram method. Means simply we can take this vector, we can place at the tail of this vector. So it has to be parallel. So this vector is little bit slanted down, so it has to be parallel to this vector. So these two vectors are almost parallel. Now we can take the second vector, we can draw at the head of this one. So these two vectors also have to be parallel, this one and this one. Now simply we can draw the resultant. So the resultant of these two has to be from the tail of these two to the head of these two vectors. So this is our resultant. So simply we can use letter capital R for this. So the answer for this question has to be C. So C is the correct. Simply you have to use parallelogram method and you can find the resultant force. Question 5 says a ball travels from point X to point Y around a semicircular track of radius 1.0 meter as shown. What is the displacement of the ball from X to Y? So for this question we need to understand this is our initial position, then this one is the final position, and displacement is the shortest distance between initial and final position. It simply means that this is our displacement. So this is displacement. This is semicircular and the radius of this one is r. So it means this distance, this has to be equal to 2r. So simply we can say in this case d, this is equal to 2 times r. So it means this is equal to 2.0 meters, and direction of this one is due south. So this is due south. So the answer for this question has to be B. Displacement is a vector. Question 6 says a rock is launched vertically upwards from the surface of Earth. An identical rock is launched vertically upwards from the surface of Mars. Each rock is launched with an initial velocity of 12 meters per second. Each rock reaches its maximum height above the surface before returning back down to the surface. The velocity time graph for each rock is shown. In both cases air resistance is negligible. We need to find out the difference in the maximum heights of the rocks. So first of all we can sketch. We can imagine this is our beautiful planet, and from the surface of our beautiful planet we throw a rock, and the initial velocity of the rock is given, that is equal to 12 meters per second. This rock will go up and then it will come down to the surface of the planet. We can also assume we have Mars here, so we are standing at the surface of the Mars and we throw a rock, identical rock, and the initial velocity of this rock is also 12 meters per second. This rock will also go up and then this will come back. The height they will reach, maximum height will be different in these two cases, and we need to find the difference in height. Now if you look at the velocity time graph, this is for our planet. So at this point velocity becomes 0, means when it reaches at the maximum height v is equal to 0. So this is the height. So simply we can say this is the height. So this one is the height, and we have velocity time graph. It means this area under this velocity time graph, this is representing the height. So if you look at the time here, time is equal to 1.2 meters. And for the Mars also this is true. When the rock reaches the maximum height, its velocity will be equal to 0. So this is the height. So this one is the height. So we can say this height is HE, and this height we can say this is HM. Now if you look at the velocity time graph, we have for the Mars until this point. So velocity here is equal to 0 and this time is equal to 3.2 seconds. So it means we need to calculate area under this line. So this total area is representing the maximum height reached by the rock above the surface of Mars. So simply we need to calculate areas. So first of all we can calculate HE, height above surface of our planet, and this one will be equal to, we have 1.2, so here we have 1 by 2. 1.2 means this is the base and the height is 12, and if we solve this one we will get, in this case this is equal to 7.2 meters. Now we can also calculate for the Mars. We can say this is HM, this will be equal to 1 by 2, and the time we have, that is equal to 3.2 seconds, and the initial velocity, that is 12. If we solve this one we will get 19.2 meters. So we need to find the difference, delta H. Delta H will be equal to HM minus HE, and if we solve this one we have 19.2, we have minus 7.2 meters, so we will get this is equal to 12 meters. So the height difference is equal to 12.0 meters. 12.0 meters. So our final answer for this one has to be A. Question 7 says which statement describes the mass of an object? And mass of an object, simply we can say mass is inertia of a body. Higher the mass, higher the inertia of the body, or we can say mass opposes change in velocity. Force is change in velocity. But in a very simple language, you can also say mass is amount of matter in a body. Amount of matter in a body. In a very simple way, we can say amount of matter in a body. So we can say this is also represents mass. But if you look at given options, it is given to us the force the object experienced due to gravity. No, this is the weight. So this is not right option. So this is not correct. Momentum of object before a collision. So this is just representing momentum. So this is also incorrect. Resistance of the object to changes in motion or change in velocity. So this is correct. So this can be the answer. The weight of the object made by a balance. No. So this is also incorrect. Weight, mass and weight, they are two different quantities. So the answer for this one has to be C. Question 8 says a submarine of total mass 3,200 kg is at rest under water. The total mass of the submarine is suddenly decreased by 200 kg by pumping water out of the submarine horizontally in a negligible time. The upthrust acting on the submarine is unchanged. Upthrust is unchanged. The change in the total weight of the submarine causes it to accelerate vertically upwards. What is the initial upward acceleration of the submarine? So we have two different cases. First of all, we have case 1. So simply we can say for case 1, it is given to us submarine is just simply at rest. And the weight of the submarine will be acting downwards and weight of the submarine will be equal to mg. So simply we can say this is equal to mg. And mass of submarine is given to us, that is equal to 3,200 kgs multiplied by value of g, that is equal to 9.81. As submarine is at rest, it's not moving vertically up and not moving vertically down. It means the upward force, the upthrust, this is also equal to mg. So we can say upthrust is also equal to this, and this is equal to mg. So this is case 1. Now if you look at the second case, for the second case it is given to us, we have weight of the submarine. Weight of the submarine is acting downwards and weight of the submarine is now equal to 3000 times 9.81. Mass has been decreased by 200 kgs, but upthrust remains unchanged. So we can draw arrow for upthrust. So upthrust remains unchanged. So upthrust in this case is greater than weight now. Upthrust is equal to 3,200 times 9.81. In this case, acceleration is equal to 0, but in this case, submarine will accelerate vertically upwards because upward force is greater than downward force. And we need to calculate A. In order to calculate A, simply we can write down here that A has to be equal to the net force on the submarine divided by total mass of the submarine, m total. And net force is the difference between these two. So we can write down 3,200 minus we have 3,000, and this one we can multiply with 9.81 divided by, this has to be divided by 3000. This is the mass of the submarine. Now if we solve this one, our answer should be equal to 0.654 meters per second per second. So the answer for this question is B. A beautiful question, how to apply Newton's second law of motion. Very nice question. Question 9 says a box in A slides with increasing speed down a rough slope from point P to point Q. The slope surface exerts a constant frictional force on the box. As the box moves from P to Q, there are changes to the magnitude of its acceleration and total resistive force acting on it. Which row describes the changes? So for this one, first thing we need to understand, as the box is moving down, speed of the box is increasing. So as the speed of the box is increasing, so we can write on speed. So the effect of air resistance has to increase because air resistance depends on air resistance it depends on speed. If the speed increase, air resistance will increase. You can also simply imagine it is moving in the air. So here are air particles. So you can also imagine there is a sea of air, so it is moving in the air. So as this box is moving in the air, it will hit air particles. For example, if I imagine there is a particle is here, air particle here, this box will apply force on this air particle to the right, and this air particle then, as a reaction, it will apply force on this box to the left. If this box hit harder air particles, it will exert more force on air particle, so the reaction force on the box also will be greater. And so that's the reason, as speed of the box increases, air resistance also increases. As air resistance increases and friction remains constant, so simply we can say the resistive force, total resistive force increases, because total resistive force is the sum of friction plus air resistance. Air resistance increase, it means total resistive force increases. As total resistive force increases with time, with speed, so what is the effect on acceleration? So we can draw the forces acting on the box. So there is one force, that is mg is acting vertically downwards, and there will be normal reaction force, that is normal to the surface. We can simply say this one is n, and there will be resistive force on the box. We can say this resistive force is Fr, simply we can say. And also we can assume here is the angle theta, and this angle remains constant, so we can resolve weight into two components. We can draw this arrow bit longer. So this is the weight, so we can resolve into two components. This angle also has to be theta if this angle is theta. So this component of the weight is acting vertically downwards, so this component will balance normal reaction force, and this component of the weight has to be mg cosine of theta, because this is with angle. This component of the weight, that is down the slope, this one has to be mg sine of theta. So in this case, along the plane we have mg sine of theta minus we have Fr, and this is equal to ma. In this case, as Fr is increasing, so Fr is increasing, but this one is constant, so it simply means that A has to, this is mass is constant, so A has to go down because the net force is decreased. So simply we can say acceleration will decrease. So acceleration is decreasing with time, but the speed is increasing, so acceleration is decreasing with time. How about the resistive force? Resistive force is increasing. So if you look at the given option, resistive force increases, so this can be possible, but this one has to decrease, so this is not possible. Resistive force increase, yes. Acceleration decrease, yes. So if you want to write down acceleration here, you can also write down like this. So acceleration is equal to mg sine of theta minus Fr divided by mass of the block. So this is mass of the block. As this is constant, this quantity is not changing, but this quantity is increasing, so it means this has to decrease. So that's the reason answer for this question has to be D. Question 10 says two balls x and y approach each other along the same straight line and collide. The collision is perfectly elastic. Their initial speeds are u sub x and u sub y respectively. After the collision, they move apart with speed vx and vy respectively. Their directions are shown in this figure. Which equation is correct? In order to answer this question, first of all, imagine that we have one ball x. Let's say this is ball x, and here we have one ball y. Let's say x is moving to the right with velocity u1 and y is moving to the right with velocity u2. And after collision, x continue moving in the same direction with velocity v1, and y continue moving in the same direction with velocity v2. But in this case, u1 is greater than u2, so this is very important. u1 is greater than u2, so they will collide with each other. Now for this case, you need to understand, as this is perfectly elastically, it simply means that relative speed of approach, as this is perfectly elastically, so relative speed of approach should be equal to relative speed of separation. Relative speed of separation. This is only true if Killian is perfectly elastic. So for this one, the relative speed of approach is u1 minus u2. In this case, we are taking to the right is positive. And for this part, relative speed of separation simply will be equal to v2 minus v1. And this is very simple case, and we can extend this case to this one as well. So in this case, again we will take to the right is positive, to the right is positive. So we can write down in this case u1 minus u2. This one has to be equal to v2 minus v1. Means the relative speed of approach, it has to be equal to relative speed of separation. So in this case, we are taking to the right positive. It means this velocity is positive, but this one is negative. This one is negative, and this one is positive. So u1 is ux, so this is positive. u2 is uy, but this is negative. So negative means positive. So simply we can write on this will be positive. v2, we have this is means vy, so simply we can write on this is vy minus, and this one is negative, so we have minus vx, minus vx. So simply in this case, finally you will get ux plus uy, this is equal to vy plus vx. So this is the relative speed of approach, and this is relative speed of separation. So we can say this is relative speed of approach, and this is relative speed of separation. So next time you don't need to write down the first part. You don't need to do this part next time. Simply you can remember this, and then you can follow this sign convention, and you can answer this type of problems. So this is the main idea, how to answer perfectly elastic Killian questions. In today's lesson, we have discussed first 10 questions, and I will try to upload remaining questions as soon as possible. See you in next video. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from May-June 2023, paper 1, variant 2. In the last video, we have already discussed from question 1 to question 10, and today's lesson we will start from question number 11, and we will try to discuss questions about mechanics and waves. Let's study together, let's improve together. Question 11 says a rod is pivoted at point O. A force capital F is applied to the rod at point W as shown in the figure. What is the moment of the force about O? Means about this point. So this is over pivot point. So this is our pivot point. Now we need to understand what is moment of a force. Moment of a force is also called turning effect of a force. Moment of a force means turning effect due to this force, and this one is equal to force time perpendicular distance between line of action of the force and the pivot, or we can take the perpendicular component of the force and the distance between force and the pivot. But for this question we will be applying this one, because we have the force at this point and we have the perpendicular distance between line of action of the force. So this is line of action of the force. So force is acting along this line, and the perpendicular distance we have, this one is the perpendicular distance. So this is perpendicular distance. So simply in this case we can say we have force times perpendicular distance, that is equal to O times Y. So the answer for this question has to be B. So this is how we can answer. So this is something you need to understand to answer question about moment. Question 12 says a uniform rod XY of weight 10.0 newtons is freely hinged to a wall at X. It is held horizontal by a force capital F acting from Y at an angle of 30 degrees to the horizontal as shown in the figure. We need to find out what is value of capital F. Before we answer this question, we need to understand this question is a typical type of question, means it's a repeated question. You will see this question in different past papers. So it's very important to master this type of questions, how to approach them and how to answer them quickly. So we will discuss this question in detail, so this will help you to improve your understanding. In order to answer this question, first of all, we need to look at uniform rod. Uniform rod, uniform beam. Uniform simply means that its density is the same throughout. If density is the same, it means that the center of mass is at the midpoint of the rod. So center of mass is at midpoint. So this is first thing we need to understand. Now we need to answer this question. So simply we can take the pivot at this point, at the hinge. So we don't need to worry about hinge forces. And also we need to assume in this case that the length of the rod, it is not given in the question. So we can assume the length of the rod is equal to capital L. So the distance between the pivot and center of mass of this rod has to be equal to L by 2. And also we need to resolve this force into two components. So we can resolve first of all into vertical component. Let's say this is FV. This one has to be equal to F times sine of this angle. So we have 30 degrees. This force also has one horizontal component. So horizontal component, we can say FH. This has to be equal to F cosine of 30 degrees. Now simply we need to look at moment due to these forces. If we look at moment due to this horizontal component, moment will be equal to 0 because this force is passing through the pivot. So the perpendicular distance is equal to 0. Now if you look at moment due to vertical component, moment due to this vertical component about this pivot, this one has to be counterclockwise, CCW. And moment due to weight, this one has to be clockwise. As this rod is in static equilibrium, it simply means that clockwise moment has to be equal to counterclockwise moments. Means sum of clockwise moments has to be equal to sum of counterclockwise moments. So I'm just writing simply CW is equal to CCW. Clockwise moment is due to the weight, and weight is given to us, that is equal to 10 newtons. So simply we can write on here, we have 10 newtons multiplied by perpendicular distance from pivot, that is equal to L by 2. And counterclockwise moment is due to this force. We can write on F sine of 30 degrees multiplied by the distance from the pivot, that is equal to L. Now simply we can cancel L with L. Means we can cancel this one with this, and 10 divided by 2, so we got 5 here, and F sine of 30 degrees, sine of 30 degrees is equal to 1 by 2. So F in this case is equal to 10 newtons. And this question is a repeated question. You will see the same question in different past papers as well. So the answer for this question is C. Question 13 says two solid cubes X and Y are made of material of the same density. Cube X has twice the mass of cube Y. Cube X has sides of length X. Cube Y has sides of length Y. What is the ratio X by Y? So for this question, first of all, simply we can imagine we have two cubes. So imagine that this is cube X. So we have, this is cube X. This is cube X. And the sides of cube X are X. We can also imagine each side of this cube is X, and we have another cube that is cube Y. So this is over cube Y. Cube Y has sides Y, so this is Y, this is Y, this is also Y. So the volume of this cube will be equal to X cube, and the volume of this one will be equal to Y cube. For this question, it is given to us these two cubes, they have the same density. So it means that the mass of x divided by the volume of x. This has to be equal to the mass of y divided by volume of y. For this question, it is given to us cube x has twice the mass, so we can say this is 2m, and this will be divided by x cube, and here we have this is m divided by this is y cube. We need to find the ratio between x and y. So first of all, we can cancel this m with this m. Now if we cross multiply, in this case we will get x cube. This is equal to 2 times y cube. So from here we can say x divided by y, the cube of this one, this is equal to 2. So from here, if we take cube root on both sides, we can say x over y, this is equal to 2, the cube root of this one, 2 to the power of 1 by 3. Now if we solve this one, our final answer will be equal to 1.26. So the answer for this question is A. A beautiful way, this is how you can answer this type of problems. Question 14 says a U-shaped glass tube contains liquid of density 2000 kgs per cubic meter as shown in the figure. What is the difference in pressure due to the liquid between levels P and Q? So simply we need to calculate delta P PQ, and this will be equal to rho G times delta H PQ. Density of the liquid we have, that is equal to 2000 kgs per cubic meter, and value of G is 9.81, and the difference in height means between this point and between this point, difference is 4 centimeters. So we can say this is 4.0 times 10 to minus 2. Now if we solve this one, our final answer should be equal to 780 pascals. So this is delta P between P and Q. So this is delta P between P and Q. So the answer for this question should be A. Question 15 says a steam turbine is used to drive a generator. The input power to the turbine is Pi and the output power is P naught. The power loss in the turbine is PL as shown in the figure. What is efficiency of the turbine? So efficiency simply is equal to P output, but this one has to be P out, useful P out, divided by P in, means the total input power. So we can say P input. So in this case we have P out, that is equal to P naught, and we have in this case input power, that is Pi. So the answer for this question should be D. So D is the answer. This is also a repeated question you will see in other past papers. Question 16 says a variable force is applied to ensure that a constant power is supplied to a train. Which graph best shows the variation of the force F applied with the velocity V of the train? So simply we need to find relationship between force and velocity. In this case it is given to us that power is constant and power is equal to F times V. From here we can make F the subject, so we can write down F is equal to P divided by V. P in this case is constant. P is constant. So if P is constant, it means that F and V, they are inversely proportional to each other, or we can say the product of these two has to be constant. If one is increasing, other has to decrease, so it means they are inversely proportional. So this is the point we need to understand. So they are inversely proportional. So A is the answer for this question. Question 17 says a block is released from rest and slides a distance x down a straight slope. The slope is at an angle theta to the horizontal, and slope is frictionless and a resistance is negligible. Expression of free fall is g. Which expression gives the final speed of the block? So we need to find out the final speed of the block when the block has covered distance x. So at this point we need to find out the speed of the block. So this is what we need to find out. For this question it is given to us slope is frictionless, so there is no friction. So the force of gravity on this block is acting vertically downwards, so this is mg, and also there will be normal reaction force perpendicular to the slope, means the pushing by the slope on the block, that is normal to the surface. So this is normal reaction force. Now we can resolve this weight into two components. So we have one component that is perpendicular to the slope and other component that is parallel to the slope. We can draw this component also here. So this is parallel to the slope and this component is perpendicular to the slope. This angle is theta, so this angle also has to be theta. So here we have mg cosine theta because this component is with angle, and opposite to the angle has to be mg sine of theta. So this is parallel to the slope, so we can also write down here mg sine of theta. If you look at forces perpendicular to the slope, there is no net force because block is not moving perpendicular to the slope, but the block is accelerating along the slope. Now simply we have to use F net. F net is equal to MA. So the net force on the block is mg sine of theta. This is down the slope and this is equal to MA. From here we can find out that A is equal to g sine of theta. So this is value of A. Now we have value of A. We need to find out the final speed and the acceleration in this case. Very important one. This is constant because g is constant, angle is constant. So this is constant acceleration. As acceleration is constant, so simply we can write down v square has to be equal to u square plus 2as. So we need to find out v. U is equal to 0 because it just started from rest. Initial speed is equal to 0. It started from rest. We have 2, and in this case we are taking down the slope as positive. So down the slope is positive. So A is positive. A is equal to g sine of theta and s is equal to x because this is also down the slope. So it simply means that v square is equal to this. So we have v that will be equal to g sine of theta times x. So we can write down x here, root of this one. So the root of this, if we little bit organize this, we can say this is 2gx sine of theta root of this one. So this is the final speed. So we got final speed 2gx sine of theta root of this. So the answer for this question has to be B. So B is the correct answer. A nice question about kinematics and forces. Question 18 says, what is meant by the spring constant of a spring? So if you look at Hooke's law, according to Hooke's law, F is equal to minus kx. Then this negative sign simply tells us that F and X, they are directly proportional to each other. Then negative sign means that they have opposite directions. Means when one is positive, other is negative, and vice versa. So from here we can say spring constant is equal to simply F over X. And X is extension. It is extension or it can be compression. So this can be extension, this can be compression. This is simply the change in length of the spring. So from here we can say spring constant is force per unit extension. If you look at given option, this is incorrect because this is telling us extension per unit force. So this is incorrect. This is EPE, so this is also incorrect. This is work done, this is also incorrect. So the answer for this question is D. Question 19 says, a child holds a thin metal wire that is attached to a kite. The graph shows how the extension of the wire varies with its tension. A gust of wind increases the tension from 100 newtons to 150 newtons. What is the change in the elastic potential energy of the wire caused by the gust of wind? So for this question, simply we need to calculate change in elastic potential energy. And force changes from 100 newtons to 150 newtons. So simply we need to calculate area under this line, and this shape is a trapezium. So we can simply make this one a rectangle first of all. So we can draw the line here halfway. So we can draw the line halfway here. So in this case, you can see now this area, this is approximately equal to this area. So it simply means that we can just calculate area of rectangle, and area of rectangle in this case will be equal to 1 by 2. We have 150 halfway between these two, 150 and 100, so average we have to take, so 100 plus 150 and multiply by the base, and this base is 0.15 multiplied by 10 to minus 3. So if we solve this one, our answer in this case has to be equal to 0.01875 joules, 75 joules. So we can also say this is equal to 18.7 millijoules. So approximately up to 2 SF, this is equal to 19 millijoules. So the answer for this question is B. Question 20 says a microphone detects a sound wave. The microphone is connected to a CRO. The shape of the trace on the screen of the CRO is shown in the figure. Which property of the sound wave can be determined by using only the measurement of a horizontal distance on the screen and the value of a control setting of the CRO? So which property of sound wave? So first of all, we can write down here which quantity we can determine by reading x-axis from this CRO screen. The quantity we can determine, that quantity will be equal to the horizontal distance. We can say that will be equal to the horizontal distance we will read from the CRO horizontal distance, and we will multiply that horizontal distance with time base setting. Horizontal distance, let's say we have few centimeters, this will be in centimeters, and we will multiply with time base setting, that will be equal to few seconds or few milliseconds divided by centimeters. So from here you can see that we can cancel these units. So what we will get from here, we will get time. So in this case we will get millisecond, and this one is time. So we can find time, or simply we can say we can determine time period of the wave. And if we have time period of the wave, then we can determine frequency. So frequency is equal to 1 over t. So this is the time period. So we can determine the frequency by reading x-axis of CRO graph. So by reading x-axis, we can determine frequency. In today's lesson, we have discussed 10 questions, 9 questions about mechanics, and we have discussed 1 question about waves. And in the next lesson, we will discuss all remaining questions about waves, and then we will talk about electricity and radioactivity. See you in next video. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from June 2023, paper 1 variant 2. In the last 2 videos, we have already discussed from question 1 to question 20, and today's lesson, we will start from question 21. In this lesson, our main focus will be on waves, and also we will discuss some questions from electricity as well. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these contents, and also you can have better understanding of these questions. Let's study together. Let's improve together. Question 21 says a longitudinal wave is traveling from left to right. The graph shows the variation of the displacements of the particles with distance along the wave at one instant in time. Displacements to the right are taken as positive and displacements to the left are taken as negative, which labeled point represents a compression. So first of all, we need to understand what is compression and what is rarefaction. Compression simply is a region where particles are moving towards each other. Compression means particles are moving towards each other. That region we will call is compression. And rarefaction is just opposite. Rarefaction is just opposite of compression. So we can write down rarefaction. Rarefaction is a region where particles are moving away, means they are moving away from each other, and that region we call is rarefaction. Now if you have understanding of these points, simply you need to read the graph and you can find compression. If you look at this point here, so if we look here, displacement is positive, this displacement is also positive. It means these particles, they are moving to the right. So this particle is moving to the right, this particle is also moving to the right. So this is not compression and also this is not rarefaction. Now if you look at point B, we can choose 2 points. Here we have one particle, this one has positive displacement, mean this particle is moving to the right, and if we take another particle here, this particle is moving to the left because its displacement is negative. It means this one is compression. So B, here we have compression, so we can say this is compression. So this is compression. Now if you look at point D now here, so we can also try to find out, is it compression or rarefaction? So here we have displacement positive, means particle is moving to the right, and here we have displacement negative, means particle is moving to the left. So it simply means that here we have rarefaction. So here we have rarefaction. Question was asking us to label the point that represents a compression. So the answer for this question has to be B. So B is the right answer. So this is a beautiful way how you can approach this type of problems, and this question is a repeated question. You will see this question in many past papers. Question 22 says a source X emits a sound wave of constant frequency F. The wave is subsequently received at a stationary detector Y. The frequency of the wave that is detected by Y is less than F. What could be the reason for this? So this is pretty straightforward question. This is due to Doppler effect. Due to Doppler effect, and it is given to us that observed frequency, in this case observed frequency, this is less than emitted frequency. So it means that source is moving away. Source is moving away. So pretty straightforward question. So we can simply say in this case source is moving away because listener is at rest. Listener is at rest. So the answer for this one has to be C. If you look at option A, between X and Y, wave undergoes diffraction. When waves diffract, frequency does not change. Frequency remains constant. So this is wrong. Wave undergoes reflection. When waves reflect, frequency also does not change. X is moving towards, in this case, F observe. This will be greater than F. It means source is approaching. So these points you need to understand. Maybe they can ask you questions about this next time. Question 23 says a beam of visible light is in a vacuum. What could be the frequency of the light? So simply we need to calculate frequency of visible light, and for visible light we need to understand the range of wavelength. This is what they are expecting you to remember. The wavelength of visible light. Wavelength of visible light is about 400 to 700 nanometers. We need to calculate frequency. So frequency simply will be equal to speed of light divided by the wavelength of visible light, and speed of light in vacuum is about 3 times 10 to 8 meters per second divided by wavelength, and we have the range of wavelength. You can use any value. You can use the minimum value, you can use the maximum value. Your result will be almost same. There will be not a big difference, because we can see here we have this is 10 to 11, this is 10 to 14, 1000 times greater. Here you can see this is 10 to 5, this is 10 to 8, 1000 times difference. So it will not make a big difference. So we can take a average value around 600 nanometers. So it means 600 times 10 to minus 9. Now if we simplify this one, we can write down 3 times 10 to 8 divided by, we have 600, we can say 6 times 10 to 2, times we have 10 to negative 9. So if we further simplify, we can say this is 3 times 10 to 8 divided by, we have 6 times 10 to negative 7. So we can say this is equal to about 0.5. This is 3, we can cancel with 6, we have 2, 1 divided by 2 we'll get 0.5, and here we will get this is 10 to 15. So in this case we will get 5.0 times 10 to 14 hertz. So the answer for this question has to be D. Question 24 says a vertically polarized beam of light of intensity I0 is incident normally on a polarizing filter. The transmission axis of the filter is at 45 degrees to the vertical. The beam of light transmitted by this filter is then incident normally on a second filter. The transmission axis of the second filter is horizontal. What is the intensity of the beam of light after transmission through the second filter? So here we have I0 and this light is vertically polarized, and we can say I1 after first filter, and we can say intensity of light I2 after second filter. So for this question we need to find out what is value of I2. First of all, let's try to calculate I1. So simply we need to use Malice's law, means I transmitted. This one has to be equal to I incident times cosine square theta. Cosine square theta. Now in this case we have first of all vertically polarized light. So we have vertically polarized light. So this is vertically polarized light. And the angle between vertically polarized light and transmission axis is 45 degrees. So we have angle 45 degrees. So we can also draw here, so you can see the angle between transmission axis and vertically polarized light is 45. So simply we have to use 45 degrees here. So in this case we can write down I0, we have cosine of 45 square, and cosine of 45 is 1 over root of 2 square. So it simply means that we have I0 times 1 by 2. So this is value of I1. Now we need to find out I2. I2 has to be equal to I1 times cosine square of theta, the angle between incident light and transmission axis of second filter. Now this is a little bit tricky one. Now you need to understand this light, this component of the light, it will be transmitted. So we can draw this component here. So we have this component of incident light. So this is our incident light now, and our transmission axis is horizontal. So the angle between these two, angle between this incident light and transmission axis, again this angle is 45 degrees. So simply we can rewrite here I2, this one has to be equal to I1 times cos of 45. So this is cos of 45 square of this one. So here we have I1 cos of 45, this is 1 over root of 2 square. So again we will get this is I1 times 1 by 2. So we can write on here we have I2, this is equal to I1 times 1 by 2, but value of I1 we have here. So this is I1 and this is I0. We can replace I1 with I0. So we have this is I0 times 1 by 2, and this is multiplied by 1 by 2. So we have here 1 by 2. So if we solve this one, we will get I0 times 1 by 4. So the answer for this question has to be B, and this is the way how we approach polarization questions. If this is clear to you, it means you can answer a lot of questions from polarization at this level. And if it is not clear to you, when you watch this video one time, you can stop the video, you can do question again by yourself and watch video again. And this question will make your polarization concept very clear. Question 25 says a stationary wave is formed by two progressive waves traveling in opposite directions along the same line of travel. Which statement about the two progressive waves is not correct? For a stationary wave to be formed, two progressive waves, they should have the same frequency, they must have the same wavelength, and also they must travel at the same speed. It also means that same type of waves, same type of waves, same type of waves. Means sound waves, they can form stationary wave with sound waves, but sound waves cannot form stationary waves with light waves. So the same type of waves, they must have constant phase difference. This is incorrect. This is not condition for stationary waves to be formed. So the answer for this question is A. We need to find out which statement is incorrect. Question 26 says the sound from a loudspeaker placed above a tube causes resonance of the air in the tube. A stationary wave is formed with two nodes and two antinodes as shown in the figure. Tube has height 60 centimeters and speed of the sound in the air is 340 meters per second. What is the frequency of the sound? So this is a typical type of question. You will see this question in many past papers, so this is a repeated question. You need to master how to approach this type of questions. So for this question, it is given to us, we have node here at this end, and here we have antinode. Here we have node, means at this point we have node, and at this end we have an antinode. Now we need to understand the distance between one node and one antinode, consecutive node and antinode. This distance is equal to lambda by 4. So the distance between next antinode and node is also lambda by 4, and this distance also has to be equal to lambda by 4. So in this case we have L, that is equal to 3 lambda by 4. So from here we can find out value of lambda. Lambda will be equal to 4L divided by 3, and value of L is given to us, that is equal to 60 centimeters. So 60 times 10 to minus 2, 10 to minus 2, or simply we can say this is 4 over 3 times 0.6. So this is value of lambda. Now we need to find out frequency, and frequency simply will be equal to V divided by lambda. Now we just need to plug in values and we can calculate value of frequency. Speed of sound is given, that is equal to 340. We have to divide by this, so we have 4 times 0.6 divided by 3. So we can simplify, we can say this is 340 multiply by 3 divided by 4 times 0.6. Now if we solve this one, our final answer up to 2SF has to be equal to 430 Hertz. So this is the final answer. So this is value of frequency. So the answer for this question has to be A. Question 27 says a continuous progressive water wave in a ripple tank passes through a gap in a barrier and diffracts. The width of the gap is greater than the wavelength of the wave, which change causes the wave to spread over a large angle as it passes through the gap. Large angle simply means that more diffraction. So how we can increase diffraction? So simply we can say large angle means more diffraction. More diffraction. So if gap size, this gap size, in the question it is given to us, gap size is larger than wavelength of the wave, so it means there will be less diffraction, or we can say little diffraction in this case, less diffraction. So how we can increase diffraction means how we can make more diffraction. So how we can increase diffraction. So this is what we need to answer. More diffraction can be if we reduce the gap size. So we have two options. One, we can reduce gap size. We can reduce gap size. And the second option we have, we can increase the wavelength. So we have these two options. If you look at given options, it is given to us a small decrease in the wavelength. This will make diffraction even smaller. So in this case, diffraction decrease. So we will say diffraction will go down, means there will be less diffraction. So this is not possible answer. A small decrease in the width of the gap means we reduce gap size. Yes, diffraction will increase. So this can be a possible answer. Small increase in the frequency of the wave. If frequency increase, wavelength will decrease. It means that there will be less diffraction. Small increase in the height of the barrier. Height of the barrier doesn't affect, gap size only affect. So it means it will have no effect. So the answer for this question has to be B, a typical question and repeated question. Question 28 says the diagram shows a view from above of a double slit interference demonstration. L is a monochromatic light source with a vertical filament. B is a barrier with two narrow vertical slits. S is the screen upon which interference fringes form. The intensity is I at the point on the screen where the center of the fringe pattern forms. When one of the slits is covered, what is the intensity at the same point on the screen? So in this case, center maxima will form at this point, or we can say the center bright fringe. And center bright fringe is formed when the waves are coming from these two slits. So waves are coming from these two slits, and when these two waves meet at this point and they interfere constructively, a center maxima is formed. So we can imagine these are two waves, they meet at this point, they are in phase and they form a center maxima, mean the super wave, they will form this one. We can also imagine the amplitude of this wave, let's say is A, amplitude of this wave is A. So the amplitude of this wave has to be equal to 2A. But for the second case it is given to us, one of the slit is covered, means no waves are coming from one of the slits. So for the second case, now we have only one wave. So we can write down our second case here. At this point we are talking about it, so we can write down here. So we have only this one wave coming. So the center maxima also will have only amplitude A. So amplitude A, so here amplitude A. We have to compare the intensity. So for case 1 we can say we have I naught, this is equal to I in this case, means the intensity it is given to us is equal to I, and this has to be equal to K times A square, and A square we can write down simply this is A naught. And for the second case we can say the intensity is I1. This intensity also has to be equal to K times A1 square. In this case we can also write down that I1 over A naught square. A naught, we need to understand, this is equal to 2A. So we are talking about this one, this is equal to A naught. So this is 2A square. This one has to be equal to I1 divided by amplitude of this, means A square. Now from here we can find out I1. So if we write on here, we can say I1, this one has to be equal to I naught times A square divided by, this has to be 4 times A square. So we can cancel A square with A square. So I1, this is equal to I naught by 4, and it is given to us I naught is equal to I. So simply we got here, this is I divided by 4. So this is how you can answer this question. This question is also a typical question. You will see this one in other past papers as well. So what we have done in this case, let me repeat once again. So this is the amplitude of the resultant wave, means this A naught, this is the amplitude of this resultant wave, and intensity of this resultant wave is given to us, that is equal to I, and I has to be equal to K times amplitude square. So I1 also has to be equal to K times amplitude 1 square, A1 square, and amplitude of the second wave is A. So A1 is equal to A. A1 is equal to A. We can also write on here, we are talking about this is A1. So this is A1. Now simply we need to equate these two and we can find out I1. So our final answer for this question has to be D. Question 29 says green light of wavelength 550 nanometers is incident normally on a diffraction grating and produces a diffraction pattern on a screen placed 3.5 meters from the diffraction grating. The third order maximum on the screen is a distance of 0.75 meters from the zeroth order maximum. What is the distance between two adjacent slits in the diffraction grating? This question is about diffraction grating. So first thing you need to understand. And for diffraction grating, simply we can use d sine of theta. This is equal to n times lambda. For this question, we need to find out d. So we can say d, this one has to be equal to n times lambda divided by sine of theta. We have value of n, that is 3, and we have the wavelength. Wavelength is given to us, that is equal to 550 nanometers divided by sine of angle, but we don't have value of angle. So first of all, we need to find out value of angle. But for this question, we have this distance, we have also this distance, so we can find out value of this angle. So in this case, we can say tangent of theta, this will be equal to 0.75 divided by 3.5 meters. So if we solve this one from here, we can find out value of theta. So we have tangent inverse of 0.75 divided by 3.5. If we solve this one, we will get theta is equal to 12.09 degrees. So this is value of theta. Now simply we need to place this value here, and if we solve this one, we will get d is equal to 7.88 times 10 to minus 6 meters. So this is value of d. So the answer for this question has to be C, 7.9. So up to 2SF we can write down this is 7.9 times 10 to minus 6 meters. So C is the answer. Question 30 says, which charge can be carried by a charge carrier? And charge on any charge carrier has to be integral multiple of the charge on single electron. It simply means that n has to be integer number. Integer means it can be 1, it can be 2, it can be 3, 4, and so on. But 2.5, for example, 3.5, 3.6, 5.7 something, these are not possible. So these are not integers. And E is equal to 1.6 times 10 to minus 19 coulombs. So if you look at the first one, this is smaller than 1.6, so it means this is not possible. If you look at option B, we can find value of n. So we have 4.0 times 10 to minus 19 divided by 1.6 times 10 to minus 19. So we will get about 2.5. So this is not integer, so this is also not possible. If you look at option C, for option C, we have 4.8 times 10 to minus 19 divided by 1.6 times 10 to minus 19. In this case, we will get 3. So this one is possible. This is integer. If you look at option D, we can also calculate n. So we have 9.1 times 10 to minus 19 divided by 1.6 times 10 to minus 19. If we solve this one, we will get this is about 5.68. So this is also not integer. So this is also not possible. I hope this video was helpful and you have improved your understanding of waves, and also you have improved a little bit understanding of electricity as well. In tomorrow's lesson, we will discuss remaining 10 questions, and we will discuss a lot of questions about electricity and radioactivity. And next lesson will help you to improve your understanding of electricity and also radioactivity. And if this video was helpful, please like and subscribe, because your encouragement is very important. I'll see you in next video. And if you have any questions, please leave your questions in comments. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from June 2023, paper 1 variant 2. In the last few videos, we have already discussed from question 1 to question 30, and today's lesson we will start from question 31. And today's lesson we will discuss about electricity. We will also talk about radioactivity. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these concepts, and also you can have better understanding of these questions. Let's study together, let's improve together. Question 31 says a resistor of resistance capital R is connected across the cell of electromotive force capital E and negligible internal resistance. Which single change to the circuit would lead to the largest increase in the power dissipated in the resistor? So first of all, simply we can sketch the circuit so we can visualize what is given to us. So for this question we have one cell and one resistor. Resistance of this resistor is capital R and EMF of this cell is E. So the PD across this resistor also has to be equal to E because there is no internal resistance, and also these wires are ideal wires. So this is the PD across this resistor. So we can write down the power dissipated. Power will be equal to V squared divided by R, and in this case V is equal to E. So we can say this is E squared divided by R. Now if you look at given option, for first case it is given to us doubling the value of E. So we can write down PA. So if we double the value of E, it simply means that we have 2E squared divided by R. So we will have in this case 4 times P. 4 times P. And for option B, doubling the value of R, so we can also write down PB. This is E square divided by R. Doubling the value means this is 2 times. So it simply means that the PB, this has to be equal to P divided by 2. For option C, it is given to us halving the value of E. So we can also calculate PC for this one. So we have half E. So E by 2 square divided by capital R. So in this case, we will get this is E squared divided by 4R. So it means this is P divided by 4. This is our reference. We're using this one as a reference. This is our reference. Now if we go to PD, so we can also halving the value of R. So this is straightforward. E squared divided by R divided by 2. So we will get this is 2 times E squared divided by R. Or simply we can say this is 2P. So we need to find the largest increase. So the largest increase is in first case, means for option A. This one is the largest. So the answer for this question is A. Question 32 says an electrical cable is made up of one thick strand of copper wire that is surrounded by 8 thin strands of copper wire. All 9 strands of wire are connected in parallel with each other. A cross-section of the cable is shown. Each thin strand of wire has cross-sectional area capital A and length capital L. The thick strand of wire has cross-sectional area 4A and length is equal to capital L. The cable has total resistance capital R. Which expression gives resistivity of copper? So this question is simply about resistance. We need to understand how to use this formula. R is equal to rho L by A. So this is the formula you need to answer this question. For this question, what is given to us? It is given to us that total resistance. So R is the total resistance in this case. This is given to us. So we have value of total resistance. L in this case is given to us. This is the length and this is equal to L. Each strand of wire has the same length L. So we can imagine this each strand, area of this one is A, area of this one is A, area of this one is A. Simply we can write down first of all. So each strand has the same area and this one has area that is equal to 4A. Now you can simply imagine we have these wires like this. Like my fingers, you can see like this. We can imagine is a one thick wire. So we can say the total length, each wire has the same length, so it means total length is equal to L. And how about the total area? A here representing total area. Total area. Total area in this case will be equal to 4A plus 8. So we have 4A plus 8A. Total area will be equal to 12A. Now simply plug in values, that's all. We need to calculate resistivity, so it means we can write down resistivity. This will be equal to RA divided by L. So total resistance we have, total area is equal to 12A, and total length of imaginary one cable, that is equal to L. So this is how you need to approach. So the answer for this question has to be D. So D is the right answer. Question 33 says a car has sensors for detecting the light intensity and temperature of its environment. The sensors make use of a light dependent resistor and a thermistor. The car moves from warm and dark environment to cold and bright environment. What are the changes to the resistance of LDR and thermistor? So cold and bright. Cold, so means thermistor. So cold, this is linked with thermistor. Bright, linked with LDR. Cold means that temperature is low. If the temperature is low, resistance of thermistor increases. LDR, if it is bright, resistance of LDR goes down. So it means in this case resistance of LDR will decrease and resistance of thermistor will increase. Resistance of LDR decrease, so this is right. Resistance of thermistor increase, so this is also right. So the answer for this question is C. Pretty straightforward question. You need to understand how the resistance of thermistor change with temperature and also how the resistance of LDR changes with temperature. Question 34 says a student assembles the circuit shown in the figure. Which row describes the state of the two lamps? State simply means that lamp is on or lamp is off. So if you look at this lamp, so this side is positive, so this side of diode is also positive, this is negative, so it means current can flow like this. So this will be on, so this will be on. And if you look at this diode, this is positive, this is negative, so it means current can also flow in this direction. Current can flow in this direction, but in this case this is negative, this is positive, so current cannot flow. If you look at these two lamps, this lamp also will be on because current can flow like this. So these two lamps, they will be on. For this one, current can flow like this. So it means both lamps will be on. So the answer for this one has to be D. Question 35 says Kirchhoff's first law is consequence of the conservation of which quantity? Kirchhoff's first law simply tells us that at any junction, current entering, sum of the currents entering, so we can say entering, this one has to be equal to sum of currents leaving. Entering has to be equal to leaving, and current is equal to Q over T, means Q total in a given period of time over time has to be equal to Q total over given period of time. So it simply means that first law is based on conservation of charge, means total charge remains constant. So conservation of charge. So the answer for this question has to be A. Question 36 says three identical cells each have electromotive force capital E and negligible internal resistance. The cells are connected to three identical resistors, each of resistance capital R. What is the potential difference across one of the resistors? So the best way to answer this question is, first of all, we can label this. Let's say this junction is A, and this one let's say is B, and this one is C, and this one let's say is D. So we can redraw this circuit. First of all, between A and B we have one cell. This is negative terminal, then is positive terminal, and after that we have one resistor. Resistance of this one is capital R, EMF of this one is capital E. After point B, so this is over point A and this is over point B. After point B we have negative terminal of the cell, so this is negative terminal, and we have another resistor. So resistance of this one is capital R, EMF of this one is capital E. So here we have point C. After point C we have positive terminal of the cell, negative terminal, then we have resistor, and finally we are at point D now. Point D and A, they are connected by a wire. So simply we can connect them by a wire. Now we need to find out net EMF of the circuit. What is net EMF? Net EMF of the circuit. If we look at this cell, so it has positive terminal connected with positive terminal of the next cell. EMF of this cell is also E, and resistance of this resistor is capital R. So it simply means that these two cells, they will cancel each other out. So simply you can imagine these two cells are not there. So we can redraw the circuit. If you look at this one, what is net EMF? Is simply equal to capital E. We can also redraw this circuit here. We have negative terminal, we have positive terminal, then we have one resistor here. So this is one resistor, then we have an other resistor, then we have an other resistor, and all of them, they are connected in series. So simply this is our new circuit. Net EMF is equal to capital E, and we can write down R total for this question. So R total is equal to 3 times R. So we can also calculate I. I will be equal to E divided by 3R. So this is value of current in this circuit. So our current in this case is I, and value of I is equal to this. Question is asking us to calculate value of V across any one cell. So we have resistance of this resistor, and we have current passing through the resistor. So simply we can calculate value of V. V will be equal to I times resistance of resistor. I is equal to E divided by 3R multiplied by R. So R will be cancelled with R. So simply we left with E divided by 3. So the answer for this question has to be B. So the main concept for this question is that you need to understand, if the cells, the same terminals are connected with each other, they will cancel each other if the cells are identical. So we have identical cells and positive terminal connected with positive, it means they will cancel out each other. So the net EMF is only capital E. Question 37 says, in the potentiometer circuit shown in the figure, the reading on the ammeter is 0. The light dependent resistor is then covered, and ammeter gives a non-zero reading. Which change could return the ammeter reading to 0? LDR is covered. It simply means that less light falling on LDR. So we can say less light falling on LDR. Less light falling on LDR simply means that darkness, dark. So if dark, it simply means that resistance of LDR will increase. So if resistance of LDR increase, it also means that the PD across LDR, this one will also increase. PD will increase here. And PD across this fixed resistor, this one will decrease. So PD here will decrease. PD here decrease, it means PD in this part also has to decrease. So we can say V here has to decrease. And for wire of constant resistivity and constant cross-sectional area, we need to understand V will be, so we can say V is equal to I times capital R, and capital R is equal to rho L by A, rho L by. And from here we can see that I is constant, means same current is passing through this wire. Rho, resistivity of the wire, is constant. Area of the wire is constant. So simply we can say in this case V is directly proportional to L. So V is directly proportional to L. So if V decrease, it means L of this part has to decrease. So it simply means that this sliding contact, it has to move to the left. So it has to be somewhere here now. So if you look at given options, it is given to us moving the sliding contact to the left. Yes, because the potential drop across this part decrease, so the contact has to move to the left. So the PD across this part of the wire, we can say V here, this PD has to be equal to this PD. So that's the reason sliding contact has to be moved to the left. A beautiful question on potentiometer, and also a typical type of question. You need to understand why sliding contact has to move to the left, because V is directly proportional to L. So if V go down, L has to go down. So that's the reason it has to move to the left. So the answer for this question is C. Question 38 says, what are isotopes? Isotopes are atoms of the same element with same number of protons and different number of neutrons. So we can say same protons means the same number of protons and different number of neutrons. So this is the main concept you need to understand about isotopes. Different number of neutrons. If you look at given options, it is given to us nuclei of different elements with the same number of neutrons. This is incorrect. Nuclei of different elements with same number of nucleons, also incorrect. Nuclei of the same element with different number of neutrons, this one is correct. Nuclei of the same element with different number of protons. If proton number is different, it means it is a different element. So the answer for this question has to be C. Question 39 says, a neutron is fired at uranium-235 nucleus. The neutron is absorbed by the nucleus, which then splits to form nuclei of barium and krypton. What is the number of free neutrons emitted when uranium-235 nucleus splits? So first of all, simply we can write down the equation. We have neutron. This neutron is fired at uranium-235. And this neutron is absorbed by uranium-235. So we have 235 plus 1 means 236. Atomic number remains same. And this nucleus is very, very unstable. So it will decay into barium, means this nucleus will split into barium. Barium 141 and atomic number is 56, plus krypton 92 and atomic number is 36, and also some free neutrons are also emitted. Question is simply asking us the number of free neutrons emitted in this case. So neutron and the number of free neutrons we need to find out. How many neutrons are emitted? In order to answer this question, simply we can look at atomic number and mass number. So we have mass number here. This is 236. And here we have 141 plus we have 92 plus we have the number of neutrons. We don't know this number. So if we add these two together, the sum of these two, we will get this is equal to 233, means the sum of these two. So this one has to be 3. So it means 3 neutrons are emitted. We can also look at atomic number. We have 92. So 92, here we have 56 and here we have 36. And sum of these two plus it has no atomic number, means it has no charge, 0. Sum of these two is equal to 92. It simply means that number of protons are 92. So number of protons 92. So we have 56 here, we have 36 here, so no proton here. So this one has to be number of neutron. So 3 neutrons are emitted in this process. Question 40 says, a pi plus meson has a charge of plus E, where E is the elementary charge. It consists of an up quark and one other quark. What could be the other quark in the pi plus meson? So first of all, we need to understand meson. Meson consists of one quark. It consists of one quark and one anti-quark. So this is the composition of a meson. So we can write down anti-quark. For this question, it is given to us that pi plus meson, it consists of one up quark and it consists of an other quark. So an other quark, it has to be anti-quark. So it can be anti-down quark or it can be anti-up. But C and D, they are not possible. Now if you look at the charge of up quark has charge plus 2 by 3e. So the charge on this quark has to be 1 over 3e. So it simply means that this quark is anti-down quark. Because charge on down quark is minus 1 over 3e, and charge on anti-down quark, this is plus 1 over 3e. So the answer for this one has to be A. Anti-up. anti-up quark, the charge on this one is minus 2 by 3e. So this one is not possible. So then so far this question has to be A. That's all for this video and also for this paper. I hope this video was helpful and you have improved your understanding of concepts and also you have better understanding of these questions. If this video was helpful, please like and subscribe, and also you can leave your questions in comments and I will try to answer as soon as possible. See you in next video.